Hello everyone, this is codingpros.in and today we're going to discuss a problem called the two-sum problem. According to LeetCode, this problem has been asked in Amazon 90 times, in Google 39 times, Apple 29 times, Oracle, Bloomberg, Facebook 21 times, Goldman Sachs 5 times, Nagaro, Citrix, Qualcomm, ByteDance, Airbnb, Uber, Microsoft 25 times. So yeah, this is an important problem. This is a simple problem, but yeah, this is an important one. So let's go over the problem. The problem is given an array of integer nums and an integer target. Return the indices of two numbers such that they add up to the target. So you may assume that each input would have exactly one solution and you may not use the same element twice. Okay, cool enough. So we're given an array, and let's take the first example. We're given an array of 2, 7, 11 and 15. Okay, and the target value here is 9. Okay, I'm going to write down the indexes 0, 1, 2 and 3. So what we are being asked is, we have been given a list of integers, an array of integer nums, and we are also given a target which is 9. So these two are our inputs, and we have to find two numbers such that they add to the target. In this case, the two numbers are 2 and 7. But we don't have to return these numbers, we have to return the indexes of those. So in this case, we are going to return 0 and 1. Okay, so I hope the problem is clear. Let's move on and see how we can solve this. So consider this array again, 2, 7, 11 and 15, and the target we are given is 9. I'll quickly write down the indexes. So what are we going to do? So the most obvious brute force approach to this problem is go over each of the element and check if loop through each element and find if there is another value that equals to target minus that element. So for example, if we are considering 2, we have to find whether there is an element in this part of the array such that 2 plus that element is equal to 9. Pretty simple, right? So how are we going to do this? We're going to take a for loop and we're going to fix our first number. So in this case, I fix my first number as I, and I keep it at index 0, and which makes my nums of index as 2. Cool. And I'm going to take another pointer or another variable j, which goes here to the right of that index I and searches if an element exists such that element at index I plus element of index j is equal to the target value, which is 9. If this is true, I'm going to return I and j. So now if you see, I is at 0 and j is at 1. My nums of I is equal to 2 and my nums of j is equal to 7. And we can clearly see that 2 plus 7 is equal to 9. So in this case, our solution is pretty simple. We are going to return 0 and 1. But let's take another example. Let's go over the second example, which is 3, 2, 4. Okay, 3, 2 and 4. Again, I'm going to write down the indexes 0, 1, 2, and we're going to see, we're going to use the same approach. We're going to put I at index 0 and j at index 1. Okay, now if you see, I is 0, nums of I is 3. Okay, and j is 1, nums of j is 2. Okay, let me quickly write nums of I and nums of j. So in this case, my nums of I is 3 and my nums of j is 2. 3 plus 2 is equal to 5, and the target given here is 6. I'll I'll write the target here. Target is 6. So 3 plus 2 is not equal to the target, which means we have to move forward. Cool. Okay, so I remove my j from here and put my j here. Now if you see nums of j, this is equal to 4. Nums of I is 3. 4 plus 3 is 7, which is not equal to 6. So I'm done. I don't have any more elements to go, so I iterate over I. Cool. So again, my first iteration is complete, and my second iteration, my I moves to index 1 and my j moves to index 2. So if you see nums of I here is 2 and nums of j here is 4. And we can clearly see that 4 plus 2 is equal to 6, which is our target number, as you can see in the example also. So this is our solution. So we are going to return 1 and 2. And if you see the output, it's 1 and 2. So I hope the approach is clear. We are going to use 2 for loops. We are going to iterate over each element and check, if nums of I plus nums of j is equal to the target. And we are simply going to get the answer. Cool enough. So let's go ahead and code this. As you can see, we have to return a list or a integer array which contains 2 values, which is the index. So this will be my first for loop. I equal to 0, I less than nums dot length. So I'm coding this in Java. If you want this in any other language, the approach is mostly the same. You can let me know in the comments. And we iterate I, and in the next loop we keep j equals I plus 1. Okay, again we have to go till the end of the array, which is nums dot length, and we are going to iterate j. Now what are we going to check here? We're going to check if nums of I plus nums of j is equal to the target value. If this is true, if this condition is true, which means whenever 2 and 4, when we add these two, we should get 6. So whenever we get this target number for any 2 values, we're going to return the index of those. So I'm just going to create a new integer array, and I'm just going to return I comma j. Okay, and we know that this solution, this problem always has a solution. So for the cases when this is not true, we're just going to return a null. Okay, but this will never reach the null block because this always has a solution as it's given in the question. You may assume that each input would have exactly one solution. Okay, so let's try and run this. Let's see if we get an error. Obviously we get a compilation error. I have entered 2 semicolons. Okay, here's the culprit. Let's run again. Okay, another. Oops, sorry, I haven't initialized j. So let's give it a try again. And yeah, you can see my answer is 0, 1. Expected answer is 0, 1 for this input. Let's try and submit this. Cool, this gets accepted. So yeah, this is a pretty simple approach. This is a brute force approach. Let's discuss the time and space complexity of this approach real quick. So the time complexity here is O of n square. Why? Because for each element we try to find its complement by looping through the rest of the array. Okay, so going over each element takes O of n time, and finding the other element also takes O of n time. So since these are nested, we have an O of n square solution here. Okay, and what about the space complexity of this? Space complexity. So the space complexity is only the amount of extra space we have used to solve this problem. So we have not used any extra space, we have not used any array or hash map or anything else. So the space here is O of 1. Cool. So yeah, this is the approach. If you have any questions, you can let me know in the comments, and I hope you have understood. If you have not, feel free to reach me. Cool. Thank you for watching. Have a good day.